Hi, everybody. My name is Diane Liddington, and I'm going to get started with my first screencast here for this course. My name is Diane Liddington. Like I said, I am a biology and earth and space science teacher at Central Bucks West High School out in Doylestown, PA. It's just north of Philly, about an hour north of Philadelphia. At CB West, not only do I teach science, but I also am the advisor for the STEM Research Club there. So my students design and execute their own experiments, which they turn around and enter into different competitions. A little bit about my personal life. These are my three boys. Over here on the right, my husband and my two boys are 6 and 3. They also, my husband's an engineer, so STEM's in our household, and my boys love science. We go to, that's a picture at the zoo. I don't know if you can see, there's lions back there. We go to zoos, aquariums. They love science museums. They like to figure stuff out, and my oldest loves to tinker with things and create. So not only do I teach STEM at work, but it's in our household. So to me, the Vasquez text gives a solid definition of what STEM really is, especially on an integrated fashion. But for me, it boils down to STEM is being curious and figuring things out, right? So you see something and you wonder, how does it work? How do I make it better? Why do we use that? What are the patterns that I'm seeing? And then you try to figure those things out, whether you're conducting an experiment, whether you're improving upon what you have, whether you're looking at the different technologies and tools that you can use to figure those things out, or looking at the patterns in the data and the numbers. It really boils down to bare bones. What it means is we're curious and we try to figure out things. An example of how a lab that we do in Liddington's lab, it's called BDACE. So we talk about enzymes in our biochemistry unit, and in order to model the behavior of enzymes, we do a lab called BDACE. And what it is, I don't know if you remember, they're called pop beads. They're little round beads with a nodule that sticks out, and you pop them into the other one. You can make little chains out of them. So essentially what the kids have to do is time themselves putting these beads together in different scenarios under different conditions. And then we look at how fast you can put the beads together under those different scenarios. We execute the experiment, we collect data, and then we graph it both on paper, and then we also use Excel. So the paper, the stopwatch, the calculator, the graph paper, and then the computer, the Excel technology. Those are sort of the technology components, the tools that you're using to execute the experiment. As far as science and engineering principles, a lot of the things that we use in this lab are areas where those two integrate already, right? They're using models, they have to analyze, interpret data. The one thing that's sort of lacking in that lab is the engineering component of design, like making a thing to improve. But as the Vasquez text talks about, when you're integrating STEM, you don't always have to hit all 4 in a very specific targeted fashion. You can be, 2 or 3 of the letters in the acronym. So I think the why is STEM so important, boils down to the real world, right? In the real world, the things that we do in STEM are what we have to do when we have a job in the real world. Whether you are in a STEM field or not, having that STEM literacy is so important, right? Understanding how to think critically, to problem solve, to persevere through a problem, or things that we do in STEM that we do in the real world, even if we're not in a STEM related field. As the National Academy of Science, Engineering, and Medicine video talked about, We teach the letters in pockets, but out in the real world, that's not how it works. Even if you're a scientist, you use engineering, tech, and math in order to figure out and execute your experiment. So I think everybody needs that STEM literacy that the Vasquez text discusses in order to do whatever job it is. The other thing that Neil deGrasse Tyson talked about was this need for technologically and mathematically savvy workers. Because of this need for STEM literacy. Out in the workforce, we still need to be able to think critically, problem solve, communicate with others. And as far as goals for this course, I really just want some new strategies, especially for the classroom, being able to integrate. I feel like I am guilty of the pockets and teaching science in a pocket. And I would love to have some strategies for being able to really integrate and help kids see the value and the necessity of that integration. Looking forward to the rest of the course.